This becomes important when we head into doing division. Because, I mean, so far we talked about addition and subtraction. Those behave somewhat similar to what we would expect for addition and subtraction. Is, multiply, basically add and subtract like terms. Real terms to real terms, imaginary terms to imaginary terms. There you go. When we did multiplication, since we had two terms, it's not unreasonable to suggest that we would be doing some foiling. So, not a major deal here. As far as division goes, here's where we start doing something that's very much different than the division that we've done for anything else. I mean, when we divide two real numbers, we just look to see how many times the bottom number goes into the top, and if there's any left over, we have to turn it into a fraction and so forth. When we were doing like algebraic expressions and dividing them, typically we were looking to find a way to get the bottom to some way cancel in some way. Or to write as some expression, some rational expression when we're all said and done. For this, we want to end up with a number that's in the complex number system. So, but the thing is, it's because these are these are complex numbers, which are essentially fourth dimensional numbers. It gets kind of difficult to see how many times a number goes into another number in that kind of context. So when I'm doing a division of complex numbers, my overall goal is quite a bit different from any other division. And what my goal is, and it's simply put, I want the denominator to become a real number. I don't want a complex number down there anymore, or at least a number that has an imaginary part other than having a zero imaginary part. So basically my goal, as I do G, is to turn the 2 plus 5i on the bottom into a real number in some sorts. And there's where the complex conjugate comes in, because that's really the only way I'm going to be able to do this, because if I just make an alteration to the bottom, so I'm just going to subtract 5i from the bottom, and there we go. Well, first of all, I just can't subtract the denominator from a fraction. It's going to change its value. And if I subtract the denominator, what the heck am I going to do with the numerators, and how am I going to balance that out so I'm not changing the value of the fraction? Usually when we're trying to do things like with the numerators and denominators of fractions, we are typically going to be using some multiplication, and a multiplication of 1. So what I'm going to do is, I know if I multiply the bottom by its conjugate, it's going to become a real number. So I want to multiply the bottom by 2 minus 5i. But I'm going to also multiply the top by 2 minus 5i, because what ends up happening here as a result of that is because this fraction I have right here is essentially 1. Anything over itself is 1, even in complex numbers. Anything divided by itself is 1. Since I'm multiplying this original fraction I had, this original division, by 1, I'm not changing its value in any way. So with that being said, I'm just going to FOIL the top and FOIL the bottom. Top, I FOIL out 8 minus 3i and 2 minus 5i. I get 16 minus 40i minus 6i plus 15i squared. When I FOIL out the bottom, there you go, 4 minus 10i plus 10i minus 25i squared. As usual on the bottom, the two I portions do cancel. And that's going to happen anytime you multiply conjugates together, because sometimes you can take the shortcut and say, okay, well, since I'm multiplying two conjugates together here, I can kind of ignore the O and the I portion of the FOILing process, because those two are just going to cancel out anyway. So I could say it's the same thing as getting 4 minus 25i squared, which does become 4 plus 25, which is 29. On top, though, I had to carry through, I had to kind of, group my reals and imaginaries together, and do the simplification. So 16 plus 15i squared, because 15i squared becomes 15 times negative 1, is going to become 1, and negative 40i minus 6i becomes minus 46i. So I have this point right here, I have 1 minus 46i over 29. Now again, that's not written in standard form. Remember, I had to have a real number plus a real number times I, even if that number ends up being negative and ends up becoming a subtraction rather than an addition. So what I do is I more or less kind of distribute that division of 29. So the A value becomes 1 over 29. The B value becomes a negative 46 over 29. So the overall answer I'm looking for here is 1/29 minus 46/29 I.